In this video, I want to discuss the main differences between an abstract class and an interface, and when to use either of them. This should hopefully give you a better overall understanding of both. Firstly, abstract classes are very similar to interfaces. You can't instantiate either of them. Both types may contain a mix of methods declared with or without a method block. Remember, when a method has a method block, it's a concrete method, and we can say it's implemented or provides an implementation for that method. With abstract classes, you can declare fields that aren't static and final, instance fields in other words. Also with abstract classes, you can use any of the 4 access modifiers for its concrete methods, namely public, private, protected, or the default package. You can also use all but the private access modifier for its abstract methods. An abstract class can extend only one parent class, but it can implement multiple interfaces. When an abstract class is subclassed, the subclass usually provides implementations for all of the abstract methods in its parent class. However, if it doesn't, then the subclass must also be declared abstract. You'll want to use an abstract class firstly when you want to share code among several closely related classes, animal for example with fields, name, age, and so on. You'd use an abstract class if you expect classes that extend your abstract class to have many common methods or fields, or require access modifiers other than public. You may also want to use an abstract class when you want to declare non-static or non-final fields, for example name, age. This then enables you to define methods that can access and modify the state of an object, get name, set name, and so forth. Also, you may want to use an abstract class when you have a requirement for your base class to provide a default implementation of certain methods, but other methods should be open to being overridden by child classes. In summary, an abstract class provides a common definition as a base class that multiple derived classes can share. In comparison, let's review interfaces. An interface is just the declaration of methods, which you want some classes to have. It's not the implementation. In an interface, we define what kind of operation an object can perform. These operations are defined by the classes that implement the interface. Interfaces form a contract between the class and the outside world, and this contract is enforced at build time by the Java compiler. You can't instantiate interfaces, but they may contain a mix of methods declared with or without an implementation. All methods on interfaces declared without a method body are automatically public and abstract. I've shown you previously that an interface can extend another interface. Interfaces are more flexible and can deal with a lot more stress on the design of your program because they aren't part of the class hierarchy. And we've discussed a best practice way of coding, which is commonly called coding to an interface. By introducing interfaces into your program, you're really introducing points of variation at which you can plug in different implementations for that interface. In summary, the interface decouples the what from the how and is used to make different types behave in similar ways. And just a couple of general notes here, since Java 8 interfaces can now contain default methods, i.e. methods with implementation. The keyword default is used mostly for backwards compatibility. Public static methods were also introduced in Java 8. Since Java 9, an interface can also contain private methods commonly used when default methods share common code. So when do you want to use an interface? Well, firstly, when you expect that unrelated classes will implement your interface. For example, 2 of Java's own interfaces, comparable and clonable, can be implemented by many otherwise unrelated classes. We'll be talking more about Java's provided interfaces in future videos. Another reason to use an interface is when you want to specify the behavior of a particular data type, but you're not concerned about who implements its behavior. Still, another reason for using an interface is if you want to separate different behavior. I briefly discussed some interfaces like list and queue and their implementations, array list and linked list. These are part of what Java calls its collections framework. I will be talking about this group of types and classes a lot more later in the course. Interfaces are also the basis for many of the features that are coming up, for example Lambda expressions, which were introduced in JDK 8. This is a powerful and exciting Java feature, and I'm really looking forward to introducing it to you. Another example is Java's Database Connectivity Support, or JDBC, built almost entirely with interfaces. The concrete implementation of methods is different for each database vendor and comes in the form of JDBC drivers. This enables you to write all database code without being concerned about the details of the database you're connected to. I've said that interfaces and abstract classes are both abstracted types, and abstracted types are used as reference types in code. The table on this slide is a summary of the similarities and differences. You already know you can't create an instance of either, but significantly, an abstract class lets you declare a constructor which can be called by subclasses. An abstract class participates in inheritance, but an interface doesn't. So when you use an abstract class, you use it in the extends clause of a class. When you use an interface, you use it in the implements clause of a class, record, or enum type. Although you can't instantiate an abstract class, it still inherits implicitly from java.lang.object, like every other class. But an interface type is not a class at all, so this is not true for an interface. Abstract classes and interfaces can have both abstract and concrete methods, but an interface is restricted to a subset of concrete method types, which are default methods, private methods, and both public and private static methods. An interface was designed specifically to support abstract methods. This means that every method on an interface is implicitly public and abstract when there is no method body, so these modifiers don't have to be explicitly declared. The default modifier only applies to methods on an interface, so you can't use it on a class's method or any other class type, like record or enum. Instance fields can be declared for classes, even for abstract classes, because ultimately a subclass will be instantiated and that field inherited. This isn't true of fields on interfaces. Interfaces only support public static and final fields. These modifiers are implicit, meaning if we explicitly include public, static, and final, we're really just redundantly declaring them. Alright, so that's the difference between abstract classes and interfaces. Let's move on now to the next video.